Sorry. Is the whole slide visible for you all?
Yes, it is.
Okay. So, hello guys. Today we are going to see about the continuation of the previous event. At last, we have been discussing about the software development lifecycle or AI development lifecycle, which is the first path of developing any software or any AI today. And yeah, we are the speakers. And before starting with the event, do check out the blog for the previous event for a fresh up for you, so that you can just get an idea that what we are talking in the previous event. Let's take 1 minute to scan this QR and get a glimpse about our event, our previous event.
So while
And I'll
you're
just
scanning the code and accessing it, we'll also be sharing a gist of what you can expect, like what we actually discussed from the first session. We went through the basics of AI. So what AI is, where it is used. We discussed some case studies on real life applications and how it's transforming the way we work, we think, and how it's incorporated into boosting our productivity on the whole. We also learned some keywords on what is a model, what is a prompt, what is the difference between training, validation, and all of that. So over to the link, you can read it, you can bookmark, and maybe do a quick glance before you uh, proceed with this session. Sorry to have interrupted. You can proceed.
okay. Uh, have you all scanned the QR? Can I get a thumbs up? Okay. Okay, got it. So yeah, I guess we can move forward. Okay, cool. So this is the agenda for today's event. So we are gonna have an overview about SDLC and evolution of Waterfall to Agile. I will explain you the models which is described here, and the some more models rather than Waterfall and Agile, and the phases in SDLC and Azure AI tool and integration. And then we have one extra topic, that is machine learning development lifecycle, and the case studies and future trends. And yeah, so this is our agenda for today's event. So we'll jump to what is SDLC. So SDLC stands for Software Development Lifecycle. Basically, this is the pathway for you to develop a particular software. So as a student, we might be starting a software directly, or that coding or doing the scratch coding kind of thing. But it's not the whole pathway to develop a particular software. Sometimes, how many of you here went to hackathons, participated in hackathons? Any hackathon it may be. You can just thumbs up, make it thumbs up. Oh, okay. Raise up your hands. Anything is fine. Okay. I guess in hackathons, you might be getting a problem statement and you'll be just coding for that, or you might be doing a UI UX for that. It's like that, right? So that is one of the part of the software development lifecycle. But the actual pathway to develop a particular software, the first step is feasibility study. So that's called the planning phase. So SDLC is a structured pathway. It's not that you can start from any phases. Just you can, if you get a problem statement, you can't code directly. It's not that way. It's a structured process. It's an algorithmic process. So the phases of SDLC is planning, uh, designing, develop, test, deploy, and maintain. So under this plan phase, there are many more sub phases in it. So for example, a guy is coming from Delhi. Okay, you are a team of 3 people handling a startup. Okay, so that guy is coming to give you a first project. Okay, so he asked you guys to build a application for his supermarket. So the first process, what will you do is feasibility study. So your team is capable of doing that particular project or not. Even though it may be your first project, if you get that project and if you can't do that, it will be a black mark. So the first step is doing the feasibility study. Doing the feasibility study is nothing but gathering the information that your team can proceed further with this problem statement or not. And the next one is requirement analysis. Requirement analysis is, okay, you are done setting with the team that you can move forward with it. Then what you have to do is you have to gather the requirements. Gather the requirements in the sense, it may be a hardware project, it may be a software project. If it is a software project, what kind of tools you are going to use? So those kind of cost-based analysis will be done in the requirement analysis phase, because there are many languages like TypeScript is there, JavaScript is there, and many frameworks are there. Everything will be there. But what is the optimized way of building the particular product? So you are given a particular budget. With that budget, you need to complete it because you are a startup. So that's where the SDLC will be playing a major role in planning your particular project. Because the first point is chaos versus structured development. Because if you don't follow these processes, there might be some error in your project development life cycle. It's not about one product you are building as a single individual. It's like a team. And next one is reduces risk and ensure clarity and improves quality. Absolutely. If you follow these steps, the quality of a product will be in a very high position. And it is the foundation, absolute. The feasibility study will be the foundation, and then goes coding design. This coding design and all, it's like a separate department when it comes to a startup or any organization. If you work on, there are separate people working on the requirement analysis, requirement elicitation, and those kind of things when it comes to a startup or a company it may be. So that's why the SDLCs matters, because if you don't follow this, your product might be end up in a failure or something. So just telling. Okay, next one is traditional versus modern SDLC. Like if you take any method, there will be a traditional method at first, and there will be a current method or a modern method like that. Because before AI comes, we have chatbot, right? So chatbot is a thing that we just go text and ask the getting a answer from that particular bot. We thought the chatbot is an AI for the generation who are using that. But right now AI come. So chatbot is traditional and modern is a AI. So it's like that only. Here also there is traditional software development and modern software development. We can take that as 90s and 2K. Okay, so tradition software development is nothing but waterfall model. That is one of the example for traditional model, and modern model development is agile. So if you go to any company perspective, I'm telling about your working culture. So if you go to any companies, these two models will be a base and the higher priority. So just listen to the session so that it might be helpful for you in the future. And next one is flexibility and faster development. So for faster delivery. So this is how the traditional model, modern SDLC works. In tradition, no more changes can be done during the development. But in modern development, you can even scrap all the work which you have done and you can start from the first. So that's the difference between your traditional model development and modern software development. So yeah, traditional model is waterfall. So according to the name waterfall, it is like a sequential. It will be falling from top to bottom, right? So waterfall model is a sequential uh, model. Okay, so it is a linear SDLC model with sequential phases, and there won't be no iteration. Iteration in the sense repeatable thing. You can't test more than once like that, and suitable for fixed scope projects with well-defined requirement. Yes, this is the very important point for you, that if you are in a company as a team leader and you having a new team, which is a very new team that has been introduced, they don't know much about software development and the requirements are fixed, the waterfall model will be used because it's a beginner friendly model so that you can learn with the team. So if your requirements are fixed and you have no changes in it, you can go for waterfall model. For example, when you can use this waterfall model is if you are building a portfolio website for your friend. Okay, your friend is not so sure about he's so sure about the requirement. Okay, I just want only 5 pages, and all the 5 pages, these are the content in it. It's a static website. Deploy it. So this is his requirement, because when you see the client point of view, the client is not so firm with the technical knowledge. He can just tell the requirement alone. Requirement alone in the sense he need 5 screens. Out of the five screens, one should be a login, one should be a sign up, and one should be product page, like that. Only these kind of requirement will be given by the client. So from the client, the feasibility study team will do the feasibility study, and the requirement elicitation, requirement analysis team will do the requirements, gathering the requirements. All these things will be done in a separate team. And then only you will be getting your design. So out of this requirement only, you'll be getting a design. So the requirements are fixed means you can go with the waterfall model. Why I'm telling this is, if your friend come and tell you that I don't want this particular page, scrap it instead of this page, create me another one page which is generated or that AI related page, something like that. If a requirement is like that, you can't use this model to do that, because in waterfall model, you can't do any changes while development. So only the requirements are fixed, you can go with the waterfall model. So while developing a software, if you get all the requirements in a set of sheet or paper, the fixed requirements, you can go with this, else not. So yeah, ideal for system with strict compliance needs, common in aerospace, medical, and government projects. Because why I'm telling in common in aerospace, medical, and government project is medical related projects will have a clear and cut requirements. It's not that you can change in a while, because it is structured, so that structured projects need structured model. Waterfall model is a basic model for moving ahead. So this is some of the use cases of this particular model. Yes, here it is. You can see what is it? False like structure, right? Coming step by step process. So the first one is requirement gathering and analysis, and next one is system design, implementation, testing, deployment, maintenance. Simple. So here in this model, you can't perform the implementation first and go with the requirement analysis. It's not the correct way. And if you are doing the deploy, absolutely not. You can't do that without implementation. So a waterfall model follows a structured way. The requirement gathering analysis team will work on that. System design is nothing but your UI UX. One is UI UX design, and if it is hardware design, you can go with the prototyping. All this prototyping and the Figma design, for example, I'm telling Figma. So those kind of design can take place in the system design. If you are a mechanical guy, the CAD model design, all these things will be coming under the system design. And implementation is coding. So in some here the testing is please be clear that testing here is a fourth phase. In some models it won't be like that. So the initial model, the testing is in the fourth phase. So this is the overview of the waterfall model. It's a very beginner friendly model, suitable for well structured requirements, and there is no backtracking. You can't go back and do the particular step and come forward. Only the structured way in a or the sequential manner, the waterfall model will be executed. And next one is V model. So there are many more models. Out of that, I just pick up only three models for you today. One is Agile, waterfall model, V model, and Agile. So V model is the next phase of a waterfall model. Some of the slight changes will be there. So it is the extension of waterfall model, and it works on verification and validation. Can anybody tell me what is verification and validation? Both are equal or both are different? Can anybody tell me about this? Verification and validation. You might be so familiar with Google logging and all, right? So can anybody tell what is verification and validation? Cool. I will tell you. So verification and validation is nothing but, for example, you are using your Google authentication or Microsoft authentication, right? So your what it does is you will be creating an account, and it is like verifying this password is equal to this password. It's like that. But validation is nothing but the testing process. Whether this email is located in the database, both the emails are same. So those kind of processes is not in the waterfall model, but verification and validation is one of the very important process in V model. And as same as the name of the model, V model, it will be looking like a V-shaped model. It's like a V, up and down, top, bottom up process only. So it will be looking like a V-shaped process only. I'll be showing you the diagram also. The use case of V model is critical systems like car, you can go with automatic, and medical also here. And testing planning begins at requirement phase. Yes, this is what I have to tell. The testing is done in the fourth phase in waterfall model. It's a separate phase. Here it's not like that. It will be done in the first phase itself, that is planning phase itself. So this is the V model for you. You can see the same thing only, requirement analysis, design, coding, like that only. But the verification and validation, it's like a parallel process between these two. If you do the requirement, and then you will be doing the acceptance testing. If you do the architecture and analysis, you will be doing the integration testing. You will be verification. You will be verifying that. If you design, if you do a design, for example, you are designing 5 pages. Out of 5 pages, one is a unit. Like one design you will be testing. That's called unit testing. Testing each and every screen separately. So integration testing is nothing but testing the whole project, testing the whole system, if it is working good or not. Acceptance testing is nothing but your client. Your client should accept that this is so good. So that's called acceptance testing. So there are many phases of testing as well. If you're interested, we'll be like software development lifecycle. There is one lifecycle called software testing lifecycle. So if you're interested, we'll be moving forward for that also in the upcoming sessions. So yeah, out of this, the V model works on the parallel process. Testing will be the parallelly running between the first phase, that is requirement analysis and planning. And this is how the V model will be functioning. Okay, next one. Yes, Agile model. So this is one of the very, very important model which will help you in many aspects, right? Even though in your job interviews or anything it may be. Okay. So Agile model. Agile is one of the modern software development lifecycle model. Okay. So these are some of the thing in Agile. One is iterative, incremental, and feedback driven. And Scrum, I will be explaining you about the Scrum in the later stage. For now, you can leave it. And Sprint also in the thing. But what are the difference between Agile model and the Waterfall model is the testing will be started from the day zero. Day zero is your feasibility study, right? Testing won't be a separate phase. If you uh, if you analyze and if you do some analysis and get a product, you will do the testing. For example, there are people of five in your startup. Five people are telling you something. You have asked one question that which framework I can use. Okay. So here let's take five people. 1 minute. Oh my god. Okay, let's take five people here. Deepthi is here, and Karthik is here, Lirish is here, and Krishna and Abhishek. So all these people, I have asked some questions regarding the framework, and Deepthi is telling that we can go with normal traditional HTML and CSS. Karthik is telling that we can go with React. Lirish is telling that we can go with TypeScript, and Abhishek is telling that we can go with TypeScript, and Krishna is telling that we can go with React. So out of this, we are getting a major vote for TypeScript and React, right? So we will do another kind of voting from the group of people who are going to work in the project, and then we will be fixing the analysis. That is, the requirement will be fixed accordingly. Okay, so that's how Agile works. Agile is like a feedback driven approach. You'll be working in a set of group. There is no barriers like you will be seeing in the companies, right? You will be having a separate cabin and then you'll be working in it. It's not like that. In Agile based companies, there won't be any cabin. It's like a round table approach that everybody will can give their feedback to the particular people who are working in the project and anybody can oppose it. So that's Agile. Okay, so Agile have four values. One is individual interaction, working software, collaboration, and adaptable to the change. Why adaptable to change is individual interaction. First one is individual interaction. It's nothing but if I'm telling something, even you can oppose it. It's wrong. You can change it like that. And working software. Yes, working software is one of the major principle because at the end of the day, you should show the working software to the client. It's not that your prototype speaks. Only the working software will speak. And next one is collaboration. Yes, collaboration. You should collaborate with your team accordingly to make the project successful. And next one is adaptable to change. Adaptable to changes. Your project is 90% completed. Sometimes your project is 90% completed, only 10% to go. At that time, client may be coming with another one feature to include. I don't want this feature, include this feature. You should include. That's how Agile model works. You may get, if a project should be developed in a 90-day period, day 88, one guy will come and tell that this yeah, feature should be included in the particular project. Then we have to include. That's how Agile works. Those kind of practices can't be done in the waterfall because it's a static, very beginner friendly requirement fixed model. And there are 12 more principles for that and continuous delivery and technical excellence. So each and everything you do in Agile, you will be reporting to the client. If sometimes you do because client interaction is very important so that sometimes your requirements might be so good. So this is the Agile and Scrum process. Sprint planning, daily stand-ups, review, and retrospective. So it's nothing but daily stand-up is nothing but you will be coming to the company at 9 o'clock means 9 to 9:15. They will have a meeting, right? Previous day, what you have done, what is the backlog, which you are not done, and what should we do to complete that particular process in today's meeting. So those kind of meetings they will conduct you in the industry point of view to develop a project. So those kind of things might not be there in the waterfall. So these kind of meetings will be done in this project. So in a company, they will use both the models according to their requirement. If your requirement is so high end level requirement, they will go with Agile. If it's not so high end, they will go to Waterfall or other models as well. And these are some of the roles: product owner, Scrum Master, development team. So only these kind of roles are available in model. So it might be confusing for you that what are this kind of language this guy is talking about? What is Agile? Those things and all. For now, keep in mind that if you are developing a particular product or project, first analyze the complexity of the particular project. If it is easy, medium, or high. For easy, waterfall. If it is medium, V model. If it is high end model, go with Agile because it is flexible. You can change it accordingly. So for right now, I'm asking a question. That supermarket guy is coming to your company and asking you that which model you're gonna use. I'm asking you which model you're gonna use, Agile, V model, or Waterfall. If it is Waterfall, give a thumbs up. If it is Agile, give a heart. If it is V model, just raise up your hands. Some random questions. Um, any symbols? I'm repeating again. If it is Waterfall, give a thumbs up. If it is V model, give a heart. If it is Agile, raise up your hands. Okay, I got one reaction. Okay, it's fine. So I will go with Ajay because that guy is not so technical also, and he might be changing the requirements again and again. So I will go with Ajay for this particular process. So yeah, so this is the comparison. So compared to waterfall model, that it is more adaptive and you'll get better designs as well and faster delivery of your project because you're doing you're not doing a stepwise process. Everything is combined in a way that you can get a faster delivery of your project. Cool. So this is the diagram: planning, requirement analysis, designing, building, testing. You will be doing it again and again. That's how the agile works. You can in waterfall you can do it more than once. Here you can repeat the steps again and again to get the project sorted. So these are the this is how your software development lifecycle works. So if you are going to any hackathon from now, tell that coding is not the first phase or design is not the first phase. First phase is feasibility study. The next one is gathering the requirement, and next phase is design. Next one is implementation and maintenance. I mean deployment and maintenance. This is how your software should be developed. Okay. So next one is what is not only these three models are under software development lifecycle. There are many more models like incremental model and what is that? Spiral model. You can check it out in the internet for even more related models. For an overview, I just taken an easy model, medium model, and the high-end model. Okay. So next, coming to our topic, what is AI in SDLC? So AI aids in planning, coding, testing, deployment. Yes, nowadays AI helps you to code. AI helps you to plan a structured document of your requirements, and AI helps you even to deploy it sometimes. And next one is, for example, is AI for test case generation. I will explain you what is test case generation is about in the upcoming slide. Okay. What is Azure AI? So we will be jumping to Azure a little bit and how these SDLC work in Azure AI. So Azure AI is it's nothing but Azure is a platform. It's cloud given by Microsoft, and there are many services available in Azure, like Azure ML and OpenAI and voice, speech as a service, text as a service, Foundry. Those kind of services are available in Azure. That's called Azure AI. So it supports AI model and training and deployment. Basically, there is one software called ML Studio, Azure ML Studio, where you can just drag the blocks, what you have to do. Everything will be, for example, you're having a block called testing. If you drag and drop that, the testing process will be done for your particular data set. That's called ML Designer. You can check it out in the Azure ML Studio if you have time. Cool. AI in planning and requirements. So AI with requirement analyst and effort estimation. Azure OpenAI can summarize a structured feedback. Okay. I'll tell you an example about you are building a real-time stock project. Every engineer will do that because it's a beginner-friendly project. It's like real-time stock prediction. Okay. What you can do is if you are building that, It is a very normal project. What you can add it is you can make a recommendation system. How you can make a recommendation system is using Azure OpenAI. You can do a summarized thing. It will be telling you that it is the best time to buy a stock. So the high low values will be displayed in the software, and with that AI will be analyzing that in that particular time. If you buy that stock, you can get a profit. So those kind of thing can be done using AI. It can summarize the text which is there in the particular software. That is one of the use case of AI planning and requirement. And next one is design and development. It will suggest you architectures. Example is GitHub Copilot, because even for doing your PPT, there is one option called VBA code. Even the AI can generate the VBA code and you can put it in the PPT in PowerPoint and get the slides sorted. So those kind of thing can be done here, and it can even draw your architecture, CAD model, anything. So high-end AI models can do all the architecture drawing and what is that? CAD design also it can do a little bit, I guess. I'm not sure about it. So next one is improve the design quality and speed. Yes, you can just make a handwritten design and development here. Cool. So these are some of the Azure tools. You can just check it out. These are some of the beginner friendly tools. One is vision, speech, language. So the vision tool is nothing but the custom vision and computer vision. In custom vision, Microsoft trained a model in it, and if you upload your image to if you want to do a object classification or image detection, object detection or image classification, anything, you can use this vision as a service to do that. So you can just you can create a service called vision service, custom vision service, and upload your image to the particular software, and it will be detecting it and classifying your object accordingly. So next one is speech. Speech is nothing but if you're typing a text, if you want to make it as a speech, if you want to read it, AI want to read it, you can use that service. It's nothing but just one click process. You can create a service and you can move forward accordingly. And language is nothing but the translator kind of thing. So that's called Azure Cognitive Services. Next one is Azure ML. So this is one of the very excellent feature in Azure. You can just even code it, hard code your ML model. You can create an ML model in Azure ML. Else you can use ML Designer. ML Designer, as I have told in the previous slide, that you can just drag and drop the blocks. It's like a pipeline kind of thing. See as a flow graph, everything will be done in one go. So if you're free and you can check it out, we'll also explain you if possible in the upcoming sessions as well. And next one is Azure OpenAI. Yes, Azure OpenAI is nothing but a service. You can use that for a multiple purposes like summarization or for recommendation, anything. Azure OpenAI can be used. So this is the some of the overview of the Azure AI tools. Cool. Next one is Azure DevOps integration. Cool. So as I have told you that software development lifecycle deals with DevOps also. DevOps is nothing but development and operation. Same concept only. You are a team of three members and you have to work accordingly. One guy is so good at requirement elicitation. One guy is so good at design and coding. And one guy is so good at test cases, writing test cases and all these things. One such software is Azure DevOps. You can just type in your Chrome, Azure DevOps. You can just get your portal in it. So it is a centralized platform where everybody can work under one organization. So if you are doing requirement elicitation also, you can do that in that particular thing. There is a thing called bots, right? He can just pin all the requirements there. Out of that, next people can use so the coding guy can use the requirements and can code it. And you can even write the test cases. Test cases are nothing but you have developed a sign up page, right? Uh, the sign up page is nothing but the username should be alphanumeric, both alphabets and numbers. The password length should be from 8 to 12. So these are some of the test cases. So for one test case, he will write the positive and negative test case. One is password length is from 8 to 12. Negative test cases more than 12. If the negative test case get passed, that's a bug in the particular code. So this is how the test cases can be written. This can also achieved using Azure DevOps platform. Okay. So yeah, if you're free, you can check out this platform as well, the Azure DevOps platform as well. Cool. So we have just seen two topics. One is software development lifecycle and some of the introduction about Azure AI and how software development lifecycle is integrated with DevOps. So starting from feasibility to maintenance. Next comes the Introduction to Machine Learning Development Lifecycle, MLDLC. This is the last topic, I guess, and Lirish will be continuing the upcoming slides. So MLDLC is a structured framework guiding the development of machine learning projects. So we can split the development into two parts. One is software development, and another one is the analyst, right? Analyst guys. So data analyst, we can call it like that as well. And it ensures consistency, reproducibility, and scalability. All these things. Actually, this scalability, accessibility, all these will be under a matrix, like software metric. Okay, it should be scalable. Like everybody can use the particular software. No lag should be there. Those kind of scalability measures will be taking while building a particular product. And the life cycle is iterative, feedback loops, and refined from the process, because it should be iterative, because if you build a ML model, you will be training it again and again until you achieve the accuracy or anything you can call. So it will be iterative only. Okay. So these are the 9 processes we will be following in ML development lifecycle. So uh, can anybody raise up your hands if you have done any one of the process while studying or learning machine learning? Out of this 9, if you have gone through any one? Okay, that's good. Any more raise hands? Did you go through any of these topics while learning machine learning? Okay, that's fine. Okay, so these are some of the 9 processes we have. First one is data collection, and next one is data processing. EDA. EDA stands for exploratory data analysis. And next one is data splitting and model selection, model training, model evaluation, hyperparameter tuning, deployment, monitoring, and feedback. So the next 15 minutes, I'm going to explain all these 9 topics so that you'll be getting an idea that how to build a machine learning model from scratch. Okay. So first one is data collection. Yes. So data collection will be depending on the feasibility study. Is that you are gonna get the structured data or unstructured data kind of thing. Like it will be a Excel data, like a row column format, or it may be an image. So you will be just clear about what kind of data it is, right? So if it is a data, I mean, structured data, you will be following a different method. If it is a image data, you'll be following a different method. So everything starts from the first process, the zeroth process. I'm sorry. So data collection, collect data from diverse sources such as API, database, IoT devices, sensors. Yes, you can get any data. It may be a satellite data also when it comes to high-end projects, and it may be a data that you're gathering from high IoT device, that is hardware data. Mostly this hardware data will not be so clean. Clean in the sense you can't get maximum data. There might be some data losses also sometimes. For sorting that only, we are having some more steps. That is the out of 9, there are some more steps to clear the data. And databases also, like for example, if you're filling the feedback form and we are getting that as Excel, that is also one data. So those kind of data collection can be done first. And next one is ensure high data quality, accuracy, completeness, and consistency, because your data should be at least 50% good. Because every field is missing means we can't move forward with that particular data. And next one is volume, variety, impact, model performance. Yes, because data set size matters your accuracy. If it is a very small data set, your accuracy score might be so good, but it is not so true that your accuracy is 90% correct. Because the data set size is only very small, it can judge only with the particular data set. You should, the data which you have collected, we should have every possibility that it should fail or pass. So that's how your data collection should be like that. So right now we are having many open source data sets as well, but you are building a very new product and you're starting with a data collection. Choose this, collect every data and clean it. Simple. So the next one is cleaning process only, exploratory data analysis, understanding the data. Exploratory data analysis deals with understanding the structure of the data and the relationship between the data. Relationship between the data is example, for example, you are having a fish disease detection data set. The data is having the what is that content about a fish. It's like the size of the fish, or the water. It may be having the water quality as well, ammonia, nitrate. All these things will be correlated to each other. So ammonia and nitrate are correlated to each other. Fish size and color will be correlated to each other. This is called exploratory data analysis. You will be understanding the relationship between the data. So in the particular data set itself, you are having a target variable. That is only one target variable. Like for example, I have told you that fish disease detection, right? So we are having a particular column with all the set of diseases. That's not our target variable. We have to find that this fish will be affected with that particular disease, right? So that's our target. So you should understand the data set and then move forward. And next one is detect outliers, anomalies, and data quality issues. Outliers are nothing but there might be some odd one out in the particular group. Right? Some in a group of 10 people, 9 people are so very funny, and one guy is like studying all the time. So he's outlier. Right here also in our example, there are values. If you are taking the structured data, the row column format data, uh, there are many values in the particular field, and some values might be out of the threshold. You will be setting a threshold value. If it is less than the threshold, it's good. If not, it's an outlier. You should remove that. So those kind of things will be done in the exploratory data analysis. And next one is visualization. Yes. Data visualization. That is another separate topic with separate softwares as well. For now, visualization is nothing but you can draw a correlation matrix. Correlation matrix is nothing but these two variables are related this much, like that. So you can choose that as well. And some of the visualization as scatter plot, correlation matrix, histograms, all these things are visualization graphs. So this is called EDA, exploratory data analysis. Next one is data pre-processing. Yes, data pre-processing is it's nothing but cleaning your data. So cleaning your inconsistent data. This one is requirement analysis kind of thing. You'll be analyzing it. What kind of thing we can do in the data cleaning process? Just analyzing it. This feature should be there, and this feature should not be there in the particular data set. All these things will be done here, and here you will be doing the implementation, cleaning the data. Cleaning the data, there are two types. One is null value treatment, and next one is removing the data. Null value treatment is if you find a field like empty field, you can either replace it with 0, or you can remove the particular field. These two things can be done in the cleaning process. Okay. And next one is feature engineering. Feature engineering is nothing but gathering the features. Only the needed features should be there in the data set. Other things you can just remove it. Just like you're having a feature ID 1, 2, 3, 4, 5, 6, 7, 8. Those things and all we can remove it. It is unnecessary. And next one is encode the categorical variable and normalize the numerical variable. So this is one of the important process: categorical variable and numerical variable. Uh, uh, Normalization deals with changing the value. We will be setting normalization is nothing but -1 to +1, changing the values from -1 to +1, and removing the outliers. This is called encode the category variable and numerical variable. Why I'm telling this is, if your data set is 19 GB, it's an Excel data only. So you can't see all the data like, yeah, I have to remove it, I have to remove that. So you can just apply the formula that the data should be from -1 to +1. If it is more than the range, remove it. Simple. Then you can pre-process the data. Cool. Next one is data splitting. This is one of the very important part. Data splitting deals with training, validation, and testing. So the 17, 15, 15, that's one of the formula that 70% of the training data, 15% of validation data, and 15% of testing data. You will be splitting it before going with the model selection or anything. You can just split the data set. It's nothing. You can just use the training data to test it. Then it will show the same accuracy only. Training data should be different and testing data should be different, but all the data should be in under one data set. Okay. So training is used for model fitting. Validation is used for hyperparameter tuning. Testing is used to evaluate your model. So by simple case, I have to tell you is training is you can just train your model that this is my data set, and telling the model that this is the data set, please understand. If the model is performing some issues, you will be validating it and finding the issue, and then you will be retraining it. And at last only you will be testing it with the separate data that this is my data. Understand if you you can keeping a testing kind of thing to the product. You can understanding this or not, like that. So that's how the data splitting works. Data splitting is nothing but training, validation, and testing 70, 15, 15. So in some of the use cases, we will do 80, 20 also. It depends upon your problem statement. So yeah, 80-20 is nothing but 80 for training and 20 for testing. So it depends on your data set as well. Cool. Next one is model selection. So model selection will also be dependable on your data set only. because there are many models, there are many machine learning models, there are many deep learning models, there are many neural networks. If you're applying a row column data set, that's a CSV data set, you will be going with your machine learning model. Like you will be performing regression, classification, clustering, or what is that? Random forest, those kind of models you will be selecting. If it is an image data set or something related to what is that? Even though that's classification, the data set is different. You will be going with some other high-end models like CNN, convolutional neural network, those kind of models. So it will be depending on your data set. The fifth step is selecting your model and evaluate the trade-off between your accuracy, computational cost, all these things. Because computational cost is nothing but while training, you might be requiring GPU as well. So those costs also you will be just have in mind as well. And next, some of the example are logistic regression, random forest, SVM, XGBoost, and neural network. These are some of the examples of your model. You can just go through it. Uh, if you select a wrong model and move forward, your model accuracy might be good, but in testing phase, your model will outperform if you don't select a correct model. Training is like eyewash, simple. Just making your model to understanding it. Main picture comes when you test the model, right? So next one is model training. Yes. Fifth step is model selection. Then you have to train that particular model. Fit the chosen model to the training data. Monitor training process with matrices like loss, accuracy. There are many matrices, performance matrices like accuracy, recall, specificity, and all these things are there. When it comes to your AI development, there are some more performance metrics like groundness, like that and all. How well it performs, like that. You can just go through when you build LLM or AI. And next one is use cross validation to ensure generalization. So training model is nothing but the 70% data. You just applying the model with your data set and you'll be training it. Next one is model evaluation. That is called validation. Uh, Validation. Use the validation slash test data to evaluate your model. That's what I told. In some of the use case, it may be 70, 15, 15. Else it's 80-20. Validation and testing will be done under the 20% data set itself. And some of the matrices are the same only: accuracy, precision, recall, F1 score, RMSE, all these things. These are some of the performance metrics you'll be using to evaluate your model. Whether your model is, if your model is 100% correct, your model is called overfitting. So it's overfitting and it's not the correct way to deploy your model. At least it should be 99 because no model, no AI is 100% correct. And next one is you should visualize those things. The same thing. Your accuracy, recall, you can visualize in the graph or anything. If you are very interested in data visualization, you can apply for data analyst role and learn Power BI, and you can go for this particular field as well to visualize the data. If you're so good at that, that's one of the field you can browse it. Okay, next one is hyperparameter tuning. Hyperparameter tuning is nothing but if your model outperforms. In training, it's working good. If in the testing, it's not working so good, you will tune your parameters. Parameters in the sense that in a model, there are many more parameters. Like if I go deep into it, it will be a very lengthy session. Max pooling, there are many layers in your model. You have to just tune it. Just make some changes. Adjust your model to perform so good. And there are some of the automated tools also, SKSet Learn, Grid Search CV, Azure Auto ML, and Azure Auto ML, it's like automated machine learning. So that's one of the process. Cool. Next one is model deployment. All these things are done. So you collected the data, you do the EDA, and you have done the data cleaning, and you have done and you have selected the model, and you train the model, and you evaluate the model, and now it's time for deployment. All the things are done. So convert your model to a file. You know about the H5 format or anything, right? You will be converting the model, and you will be using that in your project, and you can embed as an API as well. You can create an endpoint for your model and use it in your code. Some of the tools like Flask, Fast API, Docker, Azure ML, or some of the things you can use for deployment process, right? And next one is real-time deployment and batch audits. Real-time deployment is like in Power BI and all, what will you do is you can just get the real-time data. You'll be using that endpoint into it. I can visualize the data in a real-time manner. It's not static. So that's also possible in model deployment. At last, yes, the monitoring and feedback, what I'm thinking, what you are thinking, all these things will be coming into picture. Track model drift and re-evaluate the performance periodically, and log predictions and compare with the real outcomes is nothing but your beta version of your particular product. If I'm telling that this feature is not good, take it to consideration and work on it. If you develop a model and deploy it, there might be a version 2. If you deploy all the feature in version 1, there won't be version 2 of your particular product. So there might be some bug will be arising in your product. Those things and all will be, it's an endless process, right? So, and then you'll be automating the pipeline and continuous improvements will be done. That's called haptic feedback. You'll be gathering the feedback from the people around where the product will be used more. And then you will be taking that as consideration and you're developing the project as well. So that's it. That's my end of my presentation. So I'll just give you an overview about what I have explained. The first one is software development lifecycle. In that, we have discussed about 3 models: waterfall model, V model, and Agile. For different use cases, you will be selecting the model and then you will be going forward. And next one is Azure AI. Azure is a platform, a cloud platform by Microsoft, and the service offered by Azure is called Azure AI. And next one is machine learning development lifecycle. So there are 10 process, 9 to 10 processes in it, and you can start from data collection, and you can end it your machine learning development lifecycle with monitoring and feedback. Yeah, then the ladies should be taking forward the presentation. Thank you.
Hello, guys. Before proceeding with the session, we have an exciting announcement to make. So we are introducing our community. So may I have the screen, please? The one who is sharing. Right. Guys,
Okay.
can someone here share the screen?
Yes, I will do it. Sorry.
Yeah.
1 minute. I will be sharing my screen. There is some glitch into it. 2 minutes. I will be sharing.
Yeah.
So hi everyone. So once again,
Start an issue, then I will share the screen. No issues.
You can
yeah.
share your screen, Nilesh. Yeah. Okay.
Yeah.
Sorry.
Is
So
it
let me
visible,
just give a
guys?
brief overview of, yeah, it's visible. Let me just give a
Yeah.
brief overview of what the idea behind this is like. So, as Microsoft student ambassadors, our goal has always been to make technology accessible for everyone. And since AI is booming and almost every industry is utilizing AI for one task or the other, and each of us are utilizing it for day-to-day activities too. So we wanted to make a platform that helps everyone access AI education with no bias. It's accessible to everyone. It's an inclusive community. So we bring to you the Accessible AI Hub. So it's a non-profit initiative that is dedicated to making AI education and knowledge accessible to everyone, and it's completely hands-on session. So our vision is to make this a global community and provide a place where we value every member, and the opportunity is provided such a way that AI is utilized ethically and more responsibly by everyone. So this is our web page. We have the repository of all the events that we've conducted here, and you can also find the presentation, the blogs, the link to the YouTube video of the recording here. And you can find all the details here. You can also summarize it with AI if you don't have time to read everything. And we also have a fun playground where you can experiment different aspects of AI. For example, today we have the AI image playground. So if you write a description of an image, you will be able to just generate the image based on the description. And as you can see, most of this sections of the website is also created using AI tools. And in our upcoming sessions, we'll be teaching how you can make your own portfolio websites, your own websites for different applications. quickly with the help of AI. So if you're interested, just head over to the link that we'll be sharing now, the accessible AI hub.versal.app, and go to the contact section to follow us on LinkedIn, Instagram, and other platforms to get our newsletters and to stay updated on how we are teaching AI from scratch.
Okay, so let's resume today's session. Before we start, can't we have a quick glass of water? Like it's been a time, I know. So let's all have a glass of water and start today's session. Okay. Now, Kalyan briefly explained the process in machine learning and the process which we do as a ML engineer in practical life. So before we start, this is a data set which we are going to do. It's actually an inbuilt data set in scikit-learn, known as California housing data set, which has features of various houses and its prices, which we need to predict. So I have just visualized the data here in the form of data frame and have printed the first 5 rows of the data. So data pre-processing. So before we start, guys, I want to hear from you. Like, do you guys here know the actual difference between what is AI programming and traditional programming? So can I have an answer or a reaction from you? Okay. No problem. So in AI programming, what we'll do is we will give both inputs and outputs, and we'll let the model or the machine to learn and make it derive the outputs from an unknown input. But in traditional programming, what we'll do is we'll give the input and we'll derive the output using suitable algorithms. So that is the fundamental difference between traditional and AI programming. So when coming to data processing, it is the most important step in any ML project you take because it is the data is actually the brain or the knowledge base which we feed into the model. So we have to handle it with care. So as we know that x is the value and y is the target, we use x to predict y. So here y is the dependent variable and x is independent. So to break it down, uh, y is actually the thing which our model wants to predict, and using x, it will do the job. So as it is a default data set present in scikit-learn, there are no pre-processing methods which have to be done here. It's already pre-processed by them. So they have made the job easy for us today. Okay. And data splitting. This is second important task where we need to split the data into training, testing, or validation. So training is the part of data set. We can say about 75 or 80% of it, which will be used to feed the model. And testing is the one which is kept unseen or hidden, and the model is being tested and analyze its performance. To break it down, we can take training data set as the textbooks which we read and prepare for a particular examination. And the testing data set is a question paper which is completely random or unseen. So we use the training data set to train the model and test the data set to analyze the model's performance. So in today's session, we are approximately having a data set containing of 21,000 rows, I guess. Yeah, 21,000 rows in 8 columns, where the last column is the feature which we are going to predict, which is the value. So we are going to use all these 7 metrics and predict the eighth one. So model selection. Model selection is completely problem specific and data specific too. Based upon the data from a renowned library like scikit-learn for machine learning, TensorFlow and PyTorch for deep learning, we can choose the appropriate model or even we can build one. So I will also cover about these in the upcoming sessions. So from scikit-learn, for this data set, we are going to choose a linear regression. And before proceeding, there are two types of ML where one is known as supervised and then the second one is known as unsupervised. So in supervised machine learning, this is actually a supervised problem where the total data set is completely labeled. And in unsupervised learning, the data is actually chaotic and we need to reorganize it. So linear regression comes under supervised learning. So model training. So what we have done is we have spoke with our stakeholders, discussed the problem, found a data set, So partition it into training and testing and choose a model. The next step is fitting the data to the model. So here, what we'll do is we'll keep the test data set hidden and use the training one to fit the model. Fitting is actually making the model read the data set, analyze the pattern, and help it to predict the output. So after fitting is actually training the model, to be simple. So now we have the model trained and we have certain metrics to analyze its performance. For supervised learning and regression, the most famous four metrics is mean absolute error, mean squared error, root mean squared error, and R2 score. So, for beginner level, you do not know its definition or what it does. You have to make it sure that it has a decent value. Like the error value should be always lesser, and the output score should be on the greater side. Here, it's the first time, and we haven't tuned any hyperparameters. The metrics are pretty bad. And on further rounds, we can absolutely improve its performance. On improving, we have to do a procedure called hyperparameter tuning, where model has some predefined values known as hyperparameters. Like for example, let's take a car. For example, a car inbuilt has four pistons or V4 engine. To increase its performance, we have to upgrade its engine. Likewise, a model has a default parameters. We as ML engineers have to using appropriate methods like grid search CV, it basically does the job for you. It runs a series of experiments from your specified values, and among them, returns the best value for the model. So we have to use that model and increase the performance in case of machine learning. For deep learning, it's completely different. Deep learning is actually a neural network. It has the layers of neurons, and we need to make some addition subtractions among the layers and optimize few values and biases to make it perform well. Don't worry, guys. For now, I'm just going to teach about what's machine learning and how can we improve this model. So we have to do a hyperparameter tuning using grid search CV and enhance it. So as this is an introductory session, I haven't touched those topics, but don't worry. In the future sessions, we will be diving deep into every aspect of ML and make sure that you get every aspect of it. So now we can see that R2 score is pretty decent, that is 60%, which tells that our model is barely predicting. We need to improve its performance, obviously. So this is one such way of analyzing its performance. The second mostly used method is visualizing what we see. It's actually predominantly used method, and the famous library which we use is matplotlib. It's actually plotting graphs. So we are here plotting our model's performance, and yeah, it's pretty decent. But as we see that it has to be perfectly aligned to get a good score, it's okay for the initial way. So to summarize, there are actually seven key steps in ML. These are the most fundamental part. The first step is we need to choose the appropriate data set. Data set is the most important part for our model, and we need to visualize the data set. And as ML scientists, we have to know what the data set contains. And based upon the problem, we have to split the data set appropriately, and we have to pre-process the data. Now here, the data is perfectly pre-processed, but actually there's a saying like if you take a ML project, we spend 5 hours for pre-processing and 1 hour for modeling. It's actually true. Some of the columns here might be chaotic, and we have some NaN values. So if there are any missing values, the most famous technique or the technique which is currently used in industry is we have to replace the missing value with the model value. This you guys must have been familiar with statistics and probability. We have to replace the no model value of the entire column. Yeah. So after the pre-processing, we have to split the data. We have to train it, analyze it, and get it done. That's it, guys. It's that simple. So now I have shown you the manual way of coding. In the next session, using Azure ML, as Kalyan discussed, I will show how you guys can train a method without coding at all. It's basically like a plug and play activity. Yes, guys, and that's it from my side. And over to Kalyan for session.
Yeah. So
Yes.
I will just explain 1 minute. Okay. So I'll share my screen. Okay. My screen is visible, right? Okay. There are two case studies. One is test case generation. So test case generation is like using GP to generate test cases from user stories, and it's like user stories are nothing but it is like your pinpoint. You'll be just writing something and paste it in your wall, right? Just like a paper. That's called user story. So from that, GPT can generate more than for one user story. It can generate more than what is that 10 plus test cases. It's like it's not only 10. It's not limited. It is more than that. So it saved 100 plus hours a project because as a human you have to think what are the possible test cases we can use in that particular page, but AI can just think it in 1 second and just give you all the test cases. You have to just validate that you have to use the test case or not. So simple. So AI can do that. That is one process. And next is case study is bug prediction. As I have told you, the Azure DevOps AI highlight the risky modules before deployment and reduce the post-release defect, because before deployment itself, during testing, the Azure DevOps AI can highlight you the risky modules. Some modules may be having your API exposed. You all know about in your development, I guess you all use the environmental variable file, right? .env. Sometimes what people do is they want to use env and hardcode the API key in the file directly, right? What it happens if they just click on inspect and see that your API key will be exposed and they'll be using it. So cost will be high and all the vulnerability will be handling. So those kind of risky models can be explained by AI. So you can use env file, the environmental variable file, and just embed the API into it. Those kind of bug prediction can also be done using AI. Future of SDLC with AI. Yes, AI pair programmer standard, self-healing and predictive system, generator automation and smart tooling. What is pair programming is, there are two people. One guy is a developer and one guy is a tester in one project. In next project, the tester guy will do the development and developer guy will do the testing. So that's called pair programming. In this case, you should know both development and testing. Okay. So this is one of the major concept in agile software development, pair programming. Same only the development guy will do testing and testing guy will do the development in consecutive projects, which is like allotted to them. And self-healing and predictive system. One tool I have to expose, but I can't do that. That tool will do the self-healing and predictive system. If that tool make a particular error, it will automatically fixed. It's like it can automatically fixed by the particular tool directly. Okay, and automation is these are some of the future SDLCs, SDL software development with AI. So yeah, next one is MLOps and DevOps, machine learning plus operation and development plus operation. Actually, both the things can be achieved using Azure ML. That's one software where you can achieve both DevOps as well as machine learning operations, MLOps. So the key takeaways are yes, about some concepts about SDLC. It's not 100%. I won't tell you. It's like 10% of software development lifecycle. And what is Azure AI about? And next one is we learned about machine learning development lifecycle. And Lyrish explain you some hands-on, basic hands-on on how the manual coding works on developing a model as well. And then we just see some case studies regarding how AI can minimize our time and maximize our productivity as well. These are some of the key takeaways, and that's it from this session. If you want to explore more about this session, kindly scan this QR. This is our link for the second blog for today's session. We have explained everything in that blog. Just scan it and you can get the knowledge about the session.